ginger, oh so ginger, ginger maths.
Hello, let's try and do 2 videos in one day. Guys, I'm going to try and help out some of you who have been asking for help on the online tasks that have been set. Now then, in order to avoid any infringement, I have changed the questions slightly to what you've seen online. See if you can spot where I have subtly adjusted the numbers. So here's a classic example. I've had a couple of people asking me for help on these. Expand and simplify. It's something I've done with 8s and 9s. I've done a lot of it this year. Let's just, now it's really annoying. I can't actually see it on my pad here, so I'm just going to write it again. I'll try and write it again. Let's probably not write it on top of that. There we go. X plus 3 and 5x plus 4. Now when we are multiplying together two brackets, everything on the left bracket is multiplying everything on the right bracket. So what I like to do is draw lines to make sure that I've included all of the terms in that. So my x needs to multiply this 5x. Okay, so x times 5x. It's the same as 1x times 5x, or 1 times 5 is 5, and x times x is x squared. Now, because I can, I'm going to use different colours on this, just because technology allows me to do it. Now, this x also needs to multiply the 4. That jittery line. And 4 times x, or x times 4, 4x. X times 4, 4 times x. Still 4x. Let's choose red, because now I've multiplied the 5x plus 4 by x to give me 5x squared plus 4x. Now I want to multiply it by the 3. So now I'm going to take the 3 and I'm going to multiply that 5x. Now 3 times 5 is 15x. Now I've got 5x's. I multiply that by 3. I've now got 15x. And then my last term, let's choose purple, is my 3 times my 4. 3 times 4 is 12, because I know my multiplications. Now then, the final thing here to do is to simplify. So let's go back and use a boring black pen. Now, x squareds are on their own. They are the term by themselves, 5x squared. Now then, the number of x's, I've got 4x plus 15x. Now altogether, 4 add 15, that's 19. So I've got 19x. And finally, I've got my 12. So that is the process of expand and simplify. Now there are some more complicated ones. So let's see if I can show some of the more complicated ones that I've been asked about. There we go. Again, see if you can spot the subtle change of number. Let's delete what I was just doing. Okay. Now then, let's start with red. The first thing I want to do then here is I want to get rid of that 3x minus 3 all squared. Okay, I want to expand that first. So 3x, let's see if I can start this right. 3x minus 3 all squared is the same as 3x minus 3 times 3x minus 3. Okay, that's what it means. To square something, it means to times by itself. Makes a nice square shape. Could probably highlight that. I wonder if I could draw that. If I can try and draw that up at the side here. So if I want to find the area of a square that's a by a, I do a times a. I get a squared. It's a times a area. Anyway, 3x minus 3 times 3x minus 3. Everything in the left bracket multiplies everything in the right bracket. So 3x times 3x is 3 times 3 is 9. X times x is x squared, so it's 9x squared. 3x now I want to multiply by the minus 3. Now minus number times or a negative number times positive number. A negative times positive results in a negative, so that's going to be negative 9x. And I'm actually going to be doing the same thing again now, aren't I? Because I've got this negative 3 times 3x. That's going to give me another 9x. And finally, orange, my favourite. -3 times -3. Negative times negative is a positive. 3 times 3, so that's going to give me 9. And I'm going to bring all those terms together. 9x squared. The x's can come together, so that's minus 18x plus 9. Sorry for my jittery pen. Now that needs to add to this x plus 1, x minus 1. Now this is just going to all look annoying because we've got just so many steps. And I think it's the steps that people are finding a little bit tricky here in maybe the way in which they lay it out. So notice I'm working down the page to look at each part separately. So x times x is x squared. Now I'm going to do x times -1, that's negative x. I'm going to grab a different colour. I'm going to do 1 times x, so that's plus x. And now I'm going to do 1 times -1, which is -1. Negative times positive. And I'm realising in my language here I'm using the term minus and negative a lot, so I know who you are, but you might have a go at me for that. Now then, this is actually a difference of square. It's this beautiful thing, difference of square, which we have looked at. X minus a times x plus a is going to give you x squared minus a squared. Difference of square. We won't talk about that now. So simplifying what we've just got, these x's are going to cancel. Look, plus x and minus x are going to cancel, so I've just got x squared minus 1, and that needs to add to my 9x squared minus 18x plus 9. Bring all that together, I've got 10x squareds, still negative 18x plus 8, and that's my final answer. The thing is here, there's lots of different steps. This is why it's really important when you're doing these tasks that you do it with a piece of paper in front of you that you can write on, because if you're not writing this stuff down, you are going to get confused. Okay, next question. Okay, I got quite a few of these questions asked where you've got these diagrams. I've adjusted the numbers on this probably just to make it a bit of a pain in the neck for me. But anyway, A, B, and C lie on a straight line. BD I know is equal to BC, and that's depicted by the lines that are on the lines. I want to find angle X. Now I've been told that angle BDC equals 31. BDC, so remember BDC, the angle is the angle at D that's formed from the sides B and C. So that's this angle. I haven't got the pen selected. That's this angle here. That angle then is 31. And I'm told that the angle ADB is 61. Now this diagram then is definitely not drawn accurately, is it? Because what it's saying is, let's get a different colour, is that this angle here, this little angle here is ADB, and that's 61. Wow, okay, so those astute of you who are looking at this, 61 add 31 is 92, so that angle would be bigger than 90, and it certainly doesn't quite look bigger than 90. Or maybe that's just because I've changed the numbers a little bit. Maybe it was a bit nicer on your piece of work. Okay, now I want to, because this triangle on the right here is an isosceles triangle, because those two sides are the same, I know that, getting a different pen, I know this angle and this angle are equal, and they are equal to 180, take away 31, because angles in a triangle add up to 180. That's equal to 149. And if I divide that by 2, I then get the sum of each of those angles, and dividing that by 2 is going to be 74.5, which is really irritating. But 74.5, I can now find, what colour haven't I used? It's just green. I can now find this angle here, because this angle and that 74.5, they're on a straight line. Okay, so they at a point on a straight line. It's at a point on a straight line, not all the angles along the same straight line, but at a point on a line, they add up to 180. Now, if that's 74.5, using a bit of quick maths, I can't actually do quick maths anymore. That's 105.5. 105.5 is that angle there. Now I'm going to use angles inside a triangle, add up to 180 again. So what I know is this 61 plus this, oh, that's really horrible, 74.5 plus this, I can't, there's my pen, I can't see it. Way to confuse everybody. Yeah, those three angles add up to 180. So 61 add 74.5 is 135.5, and that added to x is 180. So what do I need to add to 135.5 to get to 180? I need to add 44.5. So x is 44.5. Just work your way through the diagram again. Have a pen and paper in front of you. Let's have a look at the last question. Okay, I don't want to make this video too long. It's already too long, probably for most of you. Okay, this last question, which I was asked for some help on. A, E, and B on a straight line segment. C, D, and B lie on a straight line segment. B to D, so let's start drawing on this. B to D is 4 meters, so this bit here is 4 meters. See where I subtly changed the number? C to D is 12 meters, so this bit here is 12 meters. That's that bit there. That's that bit there. And A to B, that's all the way down here. A to B is 22. Work out the length of B to E, which is this bit. Now, what you should be looking at here is similar shapes. So what I'm going to do is I'm going to really beautifully draw. There's the one shape. There's the second shape. And I apologize for my jittery hands. So this is triangle A, C, B. And this is triangle E, D. D, B. Terrible, I know. But this is always a good place to start. Oh, you can't see the B there. Okay, this is a good way to start because I can see what I've got similar shapes. So one is an enlargement of the other. And let's label on the edges that we know. I know A to B is 22. B to E is what I want to find. I'll put a question mark. C to B, I need to come back to this and add these two numbers together, don't I? So 12 add 4 is 16. I know, what else do I know? I know D to B, sorry, is 4. And I've got enough there. Okay, I've got enough to be able to answer this. So C to B, okay, this is an enlargement, isn't it? What's the scale factor? What do I multiply 16 by to get to 4? Well, 16, I need to divide it, don't I? I need to divide 16 by 4 to get to 4. Let's not forget that if we're dividing by a 4, it's the same as multiplying by a quarter. And so if I want to go to 22 to find out what B to E is, I can either divide it by 4, or I can do exactly the same thing, which is to times it by a quarter. And a nice way to get a quarter is to halve it and halve it again, which is quite nice. Halve it and halve it again, 11, 5.5. So my answer for B to E would be 5.5. Top tip there is to, oh, you can't see the 5.5. 5.5. There you go. Beautiful. Top tip, draw the two shapes separately on the piece of paper that's in front of you while you're working through these questions, and it will help you out. Let's go see if I can make some other videos. Take care, guys.